Okay, so as we said before, some of the scripts in this day, in this project, are pre-written. So the main camera is the camera that we're viewing our game at. If I zoom out right now, you can see that the main camera is sitting behind the character. And what we want to do is to set that up slightly differently. Currently, by default, when you make a new camera in Unity, you're making a perspective 3D camera. We want to make an isometric view, and because of that, we're going to use orthographic cameras. So the first thing we're going to do is to set up where the camera is positioned. So we're going to select our main camera in the hierarchy, and in the transform component, we're going to set the position to 1, 15, minus 22. We're going to set the rotation to 30, 0, 0. So position of 1, 15, minus 22, rotation 30, 0, 0. Then in the camera component, we're going to set the projection mode from perspective using the drop-down to orthographic. And finally, the size value that then appears to 4.5. And when you look at your scene view, your game view, you should see that you have an orthographic view. So just to run through those settings one more time, select the main camera, set the position to 1, 15, minus 22, rotate 30 degrees in the x-axis, the other two axes are at 0. Projection should be orthographic, which basically means 3D with no actual depth. And then the size value should be 4.5. Size is just the proximity to objects as they appear in the scene. Then a couple more camera settings. We're going to set our background to black. So when you move over to the front of the level, you'll see the background color of the camera. We don't want it to be blue. So in our camera component, we're going to click on the color block next to the word background. That's going to open up a color picker, which looks like this. I'm just going to bring that over. We're going to set this to black, so drag it all the way down to the bottom of the colors and close that panel. Then we're going to save our scene just to make sure it's up to date. And in the scripts folder, we're going to select camera. So this time we are going to create one more script. This script is a lot shorter than our player movement and quite simple, but we just wanted to give you one chance at creating a script. So whenever you select a folder in your assets, so for example, we are selecting camera in the scripts folder right now, we can go to the Create button and choose C# script. Have we got a helper that can help this guy free? One of you two guys at the back. Cool. Thanks, Elliot. Okay, so we're going to hit the Create button. We could choose C# script there, and it's going to create something called new behavior script. When you create a script, especially in C#, it's very important that you name it accurately. We're going to call this camera follow, so don't have any spaces in your file names for scripts, and try to name them in this capitalized style, capital C, capital F, camera follow.
Quick note on creating scripts like this. If you created it and then accidentally clicked off so it was briefly new behavior, then the class that it makes will be called new behavior. Yes. So you'll need to rename that when you open it.
So if I look at this one that I've correctly named now camera follow, you can see that it's written into the script for me, public class camera follow. And what you'll see is that when you open it up in Unity and switch back, Unity will say script name does not match file name. Class name does not match file name. So you need to make sure that everything in that class is named the same as the actual file, your camera follow script. So once you've named that, click open to open it up in Mono Develop. And you should see something like this. So just to run through those points, we've made a new C# script. We've set the camera background color, we've saved the scene, we've selected the camera folder as the particular folder to store this in, and then we've made a new C# script and named it camera follow, specifically capital C and F. Okay. So what we're going to do is, first off, you get start and update. in your script whenever you make a new script. But we don't want those there. So we're going to select over that code, making sure not to select the final curly bracket. We don't want that curly thing to be removed. We're going to hit backspace just to remove it. So we've got public class camera follow and the open and close curly braces. That's all that we need to begin with. James, over to you.
All right, I'm doing this one, am I? Yeah. Okay, so as usual, we're going to start with the public variables at the top. So those are the ones that can be accessed through the inspector or through other scripts. So start off, we need to have a target for this camera to follow. So we're going to make a public transform called target. Next, we're not going to make a public smoothing. We're going to make a public float called smoothing. And we're going to give that a default value of 5. So basically, our camera's going to follow the player around, but we don't want it to be super sharp. We're going to give it a little bit of lag, a little bit, just to make it a bit smoother for the player to see. So that value there is going to be how smooth it is. Lastly, we're going to make a private variable called offset. So we're going to store the offset of the camera from the player, like the distance between them at the start of the script. So what we need to do is store that, so in each update we can make sure that we have the same offset. So let's store that offset now in start. Offset is the distance from the vector from the camera to the player. So that's transform.position minus target.position.
So we're going to apply this script, once we finish writing it, to the camera. So we need to make sure that the transform position, so the position of the camera, is subtracted from the target position, the position of the player. So we're going to drag and drop. Because target's a public variable, we're going to drag and drop the player game object onto this transform target, and you'll see that in a minute.
Okay. So that's the end of our start function. We just needed to create that offset. Now in fixed update, so remember this is following every physics step, and we're going to use fixed update to move the camera because we're following a physics object. So if we used update, then it would be moving in different time to the player because the player is moving in fixed update. So we're going to use fixed update to move the camera, and we need a target position for this camera to try and reach. So the target position is going to be the position of the target plus this offset. So we're trying to find a place for this camera to be somewhere up above the level, and that's the position of the player plus this offset that we've stored. And now we need to actually move the camera, and we're going to use that. We're going to do that using a lerp. So a lerp just smoothly moves between two positions. So you get that through vector3.lerp, and the position that we want to move it to is between its current position, so transform.position, and this target position that we've just made. So what that's doing is it's saying, I've got my current position and the position I want to be. I'm going to try and move a little bit towards that. That's what this function is doing. So we've got the two vectors that we need to move between. Now we need to tell it how fast we're going to do that, and we're doing that using our smoothing variable that we stored earlier. And naturally, since we don't want it to do it 50 times a second, we're going to times by time.delta time. And that's the end of the script. Very simple.
So let's just run through it one more time. So in the PowerPoint slides that we've got here, we've moved the second part of that line onto a new line, so you don't need to worry about that too much. It will work exactly the same way as writing it all on one line. So basically, we need to go back one. So we created our public variables, the target being the way of storing the player's position, and a float called smoothing in order to give it some time over which to transition towards the position near the player. Then we created one private variable as that offset. And then in start, we set the offset to the difference between the camera's current position and the player's position. And then in fixed update, finally, we have, well, you can explain this bit, James, better than I can.
So we've got the target is the player, but we need to find the position that the camera needs to be in, which is not where the player is, it's above the player. So we need a target camera position. And that is the player's position plus this offset that we stored. So whatever that offset is at the start of the game, we're going to keep that offset throughout the game. So that's the target camera pose. And then we're setting the camera's position, so transform.position, to a point that's closer to this target camera position using a lerp.
Cool. Okay, so what we're going to do is file save the script, and switch back to Unity. And we're going to check if we've got any errors. If you have any errors, raise your hand. Okay, we've got a couple of people, one at the back, a couple of people over there, and we've got one over there. So this side of the room's still in the lead at this stage.
See, you
not to create a divide. I don't want to create a divide.
Yeah, you berated me when I started the first time.
No, I'm
now
getting
everyone's getting into the
now.
culture,
I'm
right?
getting into it,
yeah.
Okay.
There is a winner at the end of the day.
So I'm going to run through the next step for those of you who are up to date, and then I'm going to put up the slide which will catch those people up who are getting helped right now. So for those of you who are ready, what I want you to do is in the Unity editor, select camera follow and drag and drop this onto main camera. So from the project panel, drop it onto main camera. Sorry, my bad. So one more time. Select main follow, camera follow in the project, drop it onto main camera in the hierarchy. When you've done that and select main camera in the hierarchy,
you'll notice you have it twice, because you did it twice. If you have an extra, you can just right-click it and remove component. That'll get rid of it, by the way, in case you have to.
So you should see this camera follow script that I have in the lower right. You'll see that the public variables target and smoothing appear as things that we can assign to in the interface. So target is looking for something called a transform, and smoothing is a number that we can change to whatever we want. We're going to leave it at 6.
It's 5.
Or 5. Either one. Cool. Then what we're going to do is to assign the target. The target, of course, is the player. So we just drag and drop player onto the target variable.
Grab the player from the hierarchy and not the scene view. Clicking and dragging the player in the scene view is just going to move the player.
Yep. So one thing you'll notice as well is if you go to click, then drag, you lose the context of the main camera. So select the main camera, then drag and drop player on there. So basically all that's doing is it's finding the game object reference, and then it's finding the exact thing that it wants. It wants to find the transform. Okay. Then we're going to save. And then finally, we're going to save our player as a prefab. So like I said before, when we introduced the environment was saved as a prefab because we've already assigned a bunch of components to it. So if you've got something set up the way you want it, and you want to save it into the project, so we might want to use the player in other levels of the game, so we save it as a prefab. And the way that you can do that is just to drag it anywhere into the project. We happen to have a prefabs folder, but you don't need to drag it into there, but we'd like you to. So player, drag and drop from the hierarchy and drop it into the prefabs folder in the project.
One of the added benefits of turning something into a prefab, by the way, is it makes it a file asset on your hard drive, which means that you can save it outside of the project and use it in other projects, or sell it in maybe an online marketplace, potentially one that was an asset store, if such a thing existed.
That makes sense.
Yeah, that would be really forward thinking. And but yeah, so the ability to, if you turn it into a prefab, it's an asset, it's a hard drive file. You can save, export it, reuse it all over the place, and then yeah, so there's more benefits to turn things into prefabs.
Okay, so if I get the right slide, just to reiterate, we've saved our script and we've returned to Unity. We have selected the main camera and assigned the player from the hierarchy to the target variable. So what's not on the slide, because I'm a terrible person, is that we need to assign the script from the project panel to the main camera. So main camera should have the camera follow script. We've then dragged and dropped the player onto the target variable, and we've saved the finished player as a prefab in. So I want you to save your scene right now and press play, and you should have, fingers crossed, a little character that runs around and you can move the camera, should be tracking him. And we'll show you what that looks like right now. If anyone doesn't have what we're about to show you, then please raise your hand, we'll come and help you out. So you should be seeing this. Camera's now tracking around, and we can rotate like this.